Oh, sorry for the interruption. Now we are left with what this kinetic energy, that is half I into omega square. Now upon multiplying this and dividing the above equation by the moment of inertia, that is rotational energy E is rotational is equals to I square omega square upon 2I. But this I into omega is what? You know that this I into omega is jh upon 2 pi, or I square omega square is simply equals to j square h square upon 4 pi square. Hence the rotational energy is what? Upon rearranging that for this here, so substitute this value here. So for I square omega square we get j square h square upon 4 pi square, and this 2i is there, so that will be 8 pi square I. Okay, so now applying the this various quantum mechanical treatment and the Schrodinger wave equation to the given condition of this energy, we can have the general concept of this rotational energy as. Okay, so there is a detailed derivation for this rotational motion. By using this quantum mechanics and various substitution, we can finally get to the value of this E rotational is equals to h square upon 8 pi square I j into j plus 1. Okay, or sometime this h square upon 8 pi square I into c, if we take this is called as a rotational constant, it is called as a b. Okay, rotational constant. So if we express this energy in terms of nu bar. Okay, so what will be the change in the formula? H upon 8 pi square I into c, because for converting this energy in terms of frequency, we just need to simply substitute value of the hc by lambda. So 1 upon lambda will comes out to be the new bar. So just simply divide by the hc, so 1 hc 1 h get cancelled out, so we have been left with only 1 h, and here c will come into j plus 1. Okay, j into j plus 1. So whole this constant is there, that is h upon 8 pi square ic is called as a rotational constant b. Okay, so sometime you might be observed that b into j into j plus 1. So at that time the energy is expressed in the centimeter inverse or the meter inverse unit. Okay, so that you should keep in the mind also. Now next point is the frequency of rotational lines. Okay, so we will see that in the next lecture.